Okay, today's lesson is called Factoring Completely with Synthetic Division. So in yesterday's lesson, you were given the divisor. So for example, you might have been given this problem and you were told to divide by x plus 2. So in today's lesson, you're not given the divisor. You need to determine the divisor that you want to use and see if you end up with a remainder of 0. So how do we know which factors to try? Well, we're going to try anything that is a factor of negative 10. So we're going to try some factors like 1, negative 1, 2, negative 2, 5, negative 5, and 10, negative 10. So you're just going to guess one of these factors to try. You're going to do synthetic division and see if you end up with a remainder of 0. If you don't end up with a remainder of 0, you need to try something else. So really, I don't know the answer to this problem. I'm just going to guess one. I'm going to guess negative 5. And a clue is when I make up these problems, I don't usually make them up with the biggest factors. So you might not want to try the biggest factors. I just tend to choose smaller factors when I create the problems. So I'm going to put the negative 5 here. And as you know, we're going to put the coefficients across the top. Okay, so we're going to bring the 1 straight down. And if you're not familiar with this process, go back and watch yesterday's lesson and take good notes on that. Then we take the 1 and the negative 5 and multiply. Going down here, we're going to add. It's negative 1. Here we multiply to a positive 5. Adding, we get negative 2. Multiplying, we get 10. And I was a very good guesser. Honestly, I just guessed. And so we get a remainder of 0. So what that tells us is it tells us that x plus 5 is one of our factors. So we take that number we put on that little shelf there, change its sign, and put it into a factor. And now, since we started with an x cubed as our biggest power of x, and we divided by x plus 5, when you take x cubed divided by x, that gives you x squared. So that means the biggest power in our answer is x squared. So we have 1x squared minus 1x minus 2. So instead of just writing our answer as the quotient, we're writing the next step in the problem as factors. So we factored out that x plus 5, and we're left with this quadratic trinomial here. So now we just factor like you're familiar with. So we're going to use product sum method. We're going to look for numbers that multiply to give a product of negative 2 and a sum of negative 1. So basically, since 2 is prime, the only numbers that multiply to 2 are 1 and 2. What signs would they have to have in order to add to a negative 1? So in order to add to a negative 1, the 1 would have to be positive and the 2 would have to be negative. So we've factored completely. This is our answer. No need to solve. You're done after you've factored it completely. If we hadn't gotten a remainder of 0, we would have had to go up to our list and try synthetic division with a different factor. So in the next example, hopefully I'll guess wrong and you'll get to see that process. Okay, if we're factoring completely on this one, we're going to look at the factors of 20, plus and minus 1, plus and minus 2, plus and minus 4, and plus and minus 10, plus and minus 20. Okay, so usually, like I said, when I create these problems, usually I don't choose the biggest factors just when I'm creating them, so I wouldn't try the 20. I'm going to go ahead and try negative 10. So I'm just randomly guessing one to try. And then, as you know, when we do synthetic division, we're going to write these factors across the top. or write the coefficients across the top. Okay, let's bring that 1 straight down and multiply. Adding here, we get 0. 0 times negative 10 is 0. Adding, we get 33. Multiplying by negative 10, we get negative 330. Let's see subtracting. So 330 minus 40 would be 290. So 330 minus 44, I believe, is 286. Multiplying, we get a positive 2,860. So this remainder is definitely not going to be 0. Okay, so negative 10 is not going to work with our synthetic division. Let's go ahead and try positive 10. So again, I'm just randomly guessing. I'm going to write smaller because I don't know how many times I'm going to have to try. I'm just going to do this synthetic division until I get a remainder of 0. Bring the 1 down, multiply, add, multiply, add, multiply. So I can already tell that this is going in the wrong direction. These numbers are getting huge. I can tell just that I'm not going to get a remainder of 0. So I'm going to stop right there. So I've tried plus and minus 10. Let's go ahead and try a negative 5. Okay, so let's bring the 1 down, multiply, adding, multiply. So when I say multiply, I'm multiplying these numbers here to get negative 25. And then I'm going to go down and add. Multiplying negative 5 times 8 is negative 40. Ooh, I think I'm on the right track. Adding, going down, I'm going to get 4. Multiplying, I get negative 20. So I do get a remainder of 0. So I have remaining, I have factored out the x plus 5. And now notice the original problem was x to the 4th. If I take an x to the 4th and divide it by x, I'm left with an x cubed. So the biggest power of my answer is x cubed. So 1x cubed. Bring down the 5 as the next coefficient. Plus 5x squared. Plus 8x plus 4. Okay, we're not done with the synthetic division. So I'm going to erase this work on the right since that work wasn't correct anyway. So now we're going to do synthetic division with this new polynomial, the x cubed plus 5x squared plus 8x plus 4. So now we're only trying numbers that are factors of 4. Plus and minus 1, plus and minus 2, plus and minus 4. Okay, so I'm going to give you a hint now. So do you notice how we have only plus signs in our polynomial? That means I'm only going to try, let me change colors. I'm only going to try a negative number here on the shelf. Because as you know, like when I tried on this last step and did that negative 5, it puts an x plus 5 into the factor. So that means every number that's going to work is going to be a negative number because I need all my factors are going to have plus signs in them since I have all plus signs here. So I'm only going to try negative 1, negative 2, or negative 4. So I don't know. I'm just going to randomly guess what. I'm going to try negative 2. Since there's all plus signs left in the answer, it's going to be only a negative number on the shelf that works. So let's try negative 2. Bring the 1 down, multiply. So I'm going to add going down, multiply, adding, and I was a good guesser. And so multiplying here, I get negative 4, and I get a remainder of 0, which I want. Okay, so what did we have? We already had a factor of x plus 5, so that comes back. We have a new factor of x plus 2, and now the biggest power of x that remains is x squared. So we have 1x squared plus 3x plus 2. And now I factor using product sum method. The x plus 5 and the x plus 2 have to keep coming along. Multiplying to 2 and adding to 3. Well, it's got to be x plus 1 and x plus 2. So this is our answer. Make sure in your answer that you have enough x's. Since our original polynomial had x to the 4th power, we need to have 4 x's here that multiply to give x to the 4th. Since that x squared happens twice, you could write x plus 2 squared, x plus 2, the quantity squared, times x plus 5 times x plus 1. So that's another option for your answer. Okay, last one. You go ahead and try it. I am going to stop recording and try it myself. And then you can start playing again and check your answer. When I tried my synthetic division, I first tried with a 2, and I got a remainder of 20, so that didn't work. So then I tried a negative 2, and I got a remainder of 0, so that was good. So I factored as x plus 2, and then that quadratic, x squared plus 2x minus 3. And then I was able to factor that using product sum method. So this is my final answer. So if you had tried any of these numbers with your synthetic division, negative 2, negative 3, or positive 1, they would have all given you a remainder of 0. So you don't really need to guess and check that many times until you run into something that gives you a remainder of 0. And then you continue your factoring from there.